Good morning, students. So, good morning. Still, they have to come, right? Fine. So, I will be revising whatever we have discussed in the last class. So, we have discussed about metals and non-metals. Okay. Now, if I want to distinguish among these two, if I want to distinguish among these two with respect to periodic table, so naturally metals are electropositive elements. Metals are electropositive. When it comes to non-metals, they are electronegative. Right? So what do you mean by electropositive? So electropositive means yes, Stephen. Electropositive means yes, all of you are right. That's what we have discussed. Stephen and Manjunath. Yes. So that's where we have the metals which will be considered as electropositive element which can donate the electron easily. Okay. Now when I am talking about non-metals, they are electronegative. So that means they are going to take up the electron easily compared to donating the electrons. So to be short form, I can tell that they are good donors of electrons. Good donors of electron. I can here tell that poor donors of electron. Poor donors of electron. That's where I have the difference. So difference between these two. So which is that? One is good donors of electron and another one is poor donors of electron. Fine. So that's where we have the electropositive and electronegative elements. 1 minute, I will make my mobile silent mode. That's where we have the electropositive and electronegative elements. Okay. So what can be the next differences between metals and non-metals? What can be the major differences? Okay. So to be short, I can tell that they are electropositive because they are having larger atomic size. They are having larger atomic size. They are electronegative because they are having smaller atomic size. Smaller atomic size. Right? So even this one can be the differences. Larger atomic size and smaller atomic size. But very important point here is electropositive and electronegative. Now, when it comes to next part, okay, when it comes to next part, in the general, if you can tell that, in general we can tell that metals are dominating the periodic table. Dominating the periodic table. Right? Then we can tell that metals are more on the left hand side and the middle of the periodic table. Middle of the periodic table. Right? Now, non-metals are more or dominating on the right hand side. On the right hand side. Or to be more specific, yesterday someone had told, right? So that is with respect to p block elements. That is with respect to p block elements. Right? That's what we have discussed in the last class. Okay? Now we can extend further. When I am talking about electropositive, so that means they will be having low ionization enthalpy. They will be having low ionization enthalpy and more negative, okay, less negative, not more negative, less negative electron gain enthalpy. They are having low ionization enthalpy and will be having less negative electron gain enthalpy value. Electron gain enthalpy value. Now exactly opposite here. When it comes to non-metals, they are having high ionization enthalpy and they will be having more negative or highly negative electron gain enthalpy value. Okay, so this is what we can have the differences between metals and non-metals. So when I am telling electropositive, electronegative, it's understood. I am talking about ionization enthalpy and electron gain enthalpy. But still, if you want to mention that also, you can write it. So electropositive, electronegative, larger atomic size, smaller atomic size, these are the reason. This is the major reason why this difference is there, because metals are larger in atomic size and non-metals are smaller atomic size. Now due to that, they will be having lower ionization enthalpy and less negative electron gain enthalpy value. And here they will be having higher ionization enthalpy and more negative electron gain enthalpy value. So more negative means more energy will be released. That means they can take up the electron easily. That's where electronegativity comes. Now, less negative electron gain enthalpy value means where less energy will be released. That means they will take up the electron with not easier way. So therefore they are electropositive. They are poor acceptors of electron, metals. They are poor acceptors of electrons. Okay, yesterday metal and non-metal and alkali, metallic character. Okay, very good. Yes, that's what we were talking about. Fine. All of you have understood? So metals are dominating the periodic table. Metals are more on the left hand side and middle of the periodic table. Non-metals are more on the right hand side. And we know it is with respect to p block elements. It is with respect to p block element. So this is with respect to very important differences. Still we go on discuss the differences with examples also. Okay. Now in an ionic compound, if I take an ionic compound like a salt, NaCl or any other salt, if I take a ionic compound, what do you mean by ionic compound? Ionic compounds are those where there will be presence of cations and anions. So what is the charge on cations? Any one of you? What is the charge on the cations? Cations will have either positive or negative charge. Any one of you? Cations will have either positive or negative charge. Okay, someone has written, oh, many students are writing negative. Pooja, Sanya. No. Cations are positively charged. Okay, so please remember, that's where cations, which will be positively charged, and the anions, which are negatively charged. Anions are negatively charged. Cations are positively charged ions. Okay, no confusion. So now I can tell that in a ionic compound, metals will form cations. Metals will form cations. I am talking about ionic compound. Okay. Now, when it comes to ionic compound, in a ionic compound, so what do you mean by ionic compound? Ionic compounds are those which are having cations and anions. Okay. So, in a ionic compound, Rakesh, but every answer are not negative. Yes, that's what I am telling. I am talking about ionic compound where we have positive and negative. So in a ionic compound, non-metals will form anions. Non-metals will form anions. Okay? Metals and non-metals. Yes, Rohan. So I am talking about ionic compound where it will be a metal and non-metals are involved. Yesterday we have discussed, right? Extreme left hand side like alkali metal. When it's going to react with extremely right hand side, that is halogens, they will form ionic compound. So that one I am talking about. In ionic compound, metals will form cations and non-metals will form anions. Say for example, to understand this statement, in NaCl is an ionic compound. Okay. Now that's where we have sodium alkali metal, which will be Na plus, and that's where halogen Cl minus. So Cl is non-metal, which is negatively charged. Okay. Due to network, it is not connecting. Okay. For others, any network issue is there? Otherwise, Vishwas, you can once again you can rejoin. Okay. So that's where we have in NaCl, Na plus and Cl minus. Okay, where anions are Cl minus, cations are Na plus. So Na plus is derived from sodium. Yes, Dikshit. Good morning. Good morning, everyone. Okay. So that's where we have Na plus and Cl minus. Okay. So that's where we have metals and non-metals. Another difference. We are talking about another difference. That's where electropositive character. They can lose the electron easily. That's where electronegative character. They will gain the electron easily. They are all related to each other. So very important statement will be in that case. That is electropositive and electronegative. Okay, fine. So no network issue. Nice. So that's where we have the metals and non-metals. Now we have the compound. We have the compound which will be called as oxides. So oxides are those compounds where element will be forming a compound or a compound will be having one of the component as oxygen. So those type of compound will be called as oxide. So once again I will repeat. So these are the compound where oxygen will be present. Those type of compound will be called as oxides. Okay. So naturally, except fluorine, everywhere oxygen will be more electronegative. Listen to me carefully. In a redox reaction, it will help you out. So except fluorine, everywhere we have the oxygen which will be dominating as an electronegative species except fluorine. Because in the periodic table, fluorine is highly electronegative. Then comes the oxygen. Okay. So except fluorine, with any other element, if oxygen is forming a compound, naturally oxygen will be dominating. Okay. So another very important statement. Anyway, this one in detail you are going to study in your S and P block element. But you should understand that the very important statement here is metal oxides will be basic in nature. Okay, will be basic in nature. It's a very important point. Metal oxides will be basic in nature. Okay, and when it comes to non-metals, when it comes to non-metal oxides. Non-metal oxides. So which will be acidic in nature. Which will be acidic in nature. So that's where we have the metal oxide and non-metal oxide. All of you have understood? So that's where we have metal oxide and non-metal oxide. Sir, what do you mean by basic? These things you have studied in your SSLC, 10th standard, right? So basic means where H plus concentration will be low. Listen to me carefully. Acidic means where H plus concentration will be high. Okay, sorry, I am talking about basic, right? Basic means where H plus concentration will be low. Okay, and acidic means where H plus concentration will be high. For example, if I take sodium hydroxide, sodium hydroxide is basic or acidic? Sodium hydroxide is basic, right? Yes, Rakesh. So sodium hydroxide is basic because in the water or in the solution, they will be formed as Na plus OH minus. So that means there is a formation of OH minus by the sodium hydroxide. So this OH minus can react with the H plus to form the water. That's where neutralization. That's where neutralization. So don't get confused. Try to understand. Okay. So that's where sodium hydroxide I have taken as an example. Okay. So sodium hydroxide will be dissociated as Na plus OH minus. So this OH minus can react with H plus to form water. That's where we have the neutralization reaction. That's where we have the neutralization reaction. So therefore sodium hydroxide, since it is going to remove or it's going to decrease the H plus concentration, therefore sodium hydroxide is basic. Yes, Vasant, I will repeat it once again. So sodium hydroxide, it is a crystal. It's like sodium chloride ನಿಮ್ಮ table salt ಇದೆ ಅಲ್ವಾ, ಅದೇ ರೀತಿ sodium chloride will be, sodium hydroxide will be in solid form, which we will call it as a pellets. Okay, tablets ಇದ್ದಂಗಿರುತ್ತೆ. So when you go to the chemistry laboratory, you can have a look on this. So we have sodium hydroxide, which is pellet. Now when it will add it to the water, naturally it's going to dissolve. It's going to dissolve. Now whatever sodium hydroxide which was solid in the nature, when you add it to the water, it will be getting dissociated as Na plus and OH minus. That's why it is getting dissolved, aqueous. They are getting dissolved. Now this OH minus has the capacity to react with the H plus to form the water. So therefore, since sodium hydroxide is going to decrease the H plus concentration, so we can call sodium hydroxide as a basic molecule. All of you have understood? Sodium hydroxide as a basic molecule. Until here you have understood? I am not going to discuss in detail all these things. Once again in detail we are going to discuss in chemical equilibrium. But whatever I have explained now at this moment, all of you have understood why sodium hydroxide is basic? Okay, fine. So that's why, since it's going to decrease the H plus concentration, therefore sodium hydroxide is a basic molecule. Okay. Primary substance in soap preparation they will use. In the soap preparation they will use sodium hydroxide. Yes. Okay. Hagadre, when I am talking about metal oxide, now I will come back to that. Base plus metals, salt plus, no, I am not going for that, Pooja. That's fine, but I am not going for that. We will focus on here. Why metal oxides are called as basic? That is because I will take one of the example, that is sodium oxide. Whether sodium oxide is a metal oxide or non-metal oxide, it should be a metal oxide because sodium is an alkali metal. If I take sodium oxide, it will form Na2O because oxygen -2 oxidation state. Oxygen will be having -2 oxidation state. So therefore sodium will be required in 2 number because 1 sodium plus 1. Anyway, these things you are going to study in your redox reaction. So that's where I have the sodium oxide. This is nothing but sodium oxide. Now when it's going to react with water, or when you are going to add sodium oxide to the water, it's going to form sodium hydroxide. It's going to form sodium hydroxide. So therefore metal oxide is basic because they are involved in the formation of sodium hydroxide in this case as an example. Okay. So to balance the equation, 2 metal, sodium is there, so I will make it as 2, it should be balanced. So that's where we have the reason or answer why metal oxides are basic in nature. Why we are calling metal oxide as basic molecule. This is the reason. Because they will form bases in the solution. They will form the bases in the solution. So this is one of the reason why metal oxides are called as basic oxides. Whether I have reached you, all of you have understood? Okay. So whether I have reached you, any doubts? All of you have understood, right? So why metal oxide? As an example, sodium oxide I have taken. Why sodium oxide is basic in nature? Because sodium oxide by itself may not be involved in H plus decreasing, but it's going to form sodium hydroxide. Therefore, it is called as basic oxide. Okay. On the right hand side, I have written acidic oxide. A very simple example I will tell you. Especially for biology students, it will help you out. We have carbon dioxide. We have carbon dioxide. So carbon is a non-metal. May not be a strong non-metal, may not be a strong electronegative element as that of the halogen, but still carbon will be considered as a non-metal. So now we have carbon dioxide. Naturally, carbon dioxide should be a non-metal oxide. It cannot be a metal oxide. Okay. So that's where we have the carbon dioxide. All of you know this particular gas. Okay. So this particular carbon dioxide, even in our body, this reaction will be taking place. So this carbon dioxide reacts with water to form carbonic acid. To form carbonic acid, H2CO3. To form carbonic acid with water. Here sodium hydroxide is getting formed. In this case, sodium hydroxide is getting formed. But there, carbonic acid is getting formed. In the name itself it is there, carbonic acid. It's an acid. Okay? May not be as sulfuric acid, HCl. May not be a very strong acid, but it is acid. Okay? So for biology students, I will tell. In our body, carbonic acid will not be present as it is. Immediately it will get dissociated as bicarbonate and H+. It will be dissociated as bicarbonate and H+. So that's why we can see H+ is getting released. Okay, so bicarbonate ion and H+ will be formed in our body. What is the pH of our blood? 7.3 to 7.4, right? So that's where at that particular condition, carbonic acid will be present as bicarbonate. Now, once again for biology students, when your respiration is going on, in the tissues, carbon dioxide will be released, right? So that carbon dioxide cannot be present as a carbon dioxide because our blood in carbon dioxide if it is there, then in that case our body would behave as a carbonated drinks like Pepsi, Coca-Cola, right? When you put a syringe, when you pierce into our veins, bubbles will come out because carbon dioxide is there. But that will not happen because in our body, although there is a liberation of carbon dioxide by our tissues, but still they will not be present as carbon dioxide because immediately they will get converted into carbonic acid and which will get dissociated as bicarbonate. For this reaction, in our body we have an enzyme which is called as carbonic anhydrase. Okay, but otherwise carbon dioxide with water it will form carbonic acid. It will form carbonic acid. All of you have understood? Fine. So that's where we have non-metal oxide which will be considered as acidic because they are going to produce acids. Why metal oxides are considered as basic? Because they are going to produce bases. Right? All of you have understood? Okay, if you take another one which is there in your textbook, if I remember, that is Cl2O7. Okay, so related to chlorine oxide, related to oxide with respect to chlorine. Even this molecule with water is going to form perchloric acid, HClO4. It's going to form perchloric acid. This is easy to remember, carbon dioxide. That's why I gave that one. It's going to form perchloric acid. Once again, acid. Perchloric acid. So we have to balance it, right? I think it's balanced. Okay, that's where we have the perchloric acid. Chlorine oxide with water, it will form perchloric acid. So that's what. Non-metal oxide, therefore they are called as acidic oxide. Another important difference between metal and non-metal is compound. One difference is here, another difference is here with respect to that compounds. Fine, all of you have understood? Any doubts in this? Any other doubts, Sidya? So please remember, metal oxides they will be basic in nature and non-metal oxides they will be acidic in nature. Why metal oxides are considered as basic oxides? Because they are going to form base in their solution. They are going to form bases in their solution. Why non-metal oxides are called as acidic oxides? Because they are going to form acids in their solution. So that's where I have seen or we have taken the example of sodium oxide which is going to form sodium hydroxide in water. Same way, if you take carbon dioxide, in water carbon dioxide will be forming carbonic acid. Same way, if I take chlorine oxide, it's going to form perchloric acid in the solution. Okay? So that's where we have the metal oxide which will be basic and non-metal oxide which will be acidic. Fine? So someone had asked, I think, if I remember, I think last week someone had asked about valence and valency, right? Now yesterday I was talking about group 1 element and group 2 element, right? So that is with respect to alkali metals and alkaline earth metals, right? So in this case, group 1 element, they will be having one valence electron. They will be having one valence electron, and alkaline earth metals, they will be having two valence electrons. All of you will agree? They will be having one valence electron, that is alkali metals, and alkaline earth metals will be having two valence electron. If that is the case, when it comes to valency, when it comes to alkali metal, once again they have one as their valency. Once again they are having two as that valency. So what I mean to tell here is, when it comes to S block element, it is like valence electron is equal to valency of the element. Okay? So what do you mean by valency? So valency is number of electrons which will be involved in the bond formation. So what do you mean by valency? Valency is the number of electrons involved in the bond formation. Okay, all of you have understood? So that's where we have the valency. I am not talking about covalency. I am just talking about valency. Okay? Combining capacity, it may differ, Rohan. Therefore, better word is, it is the number of electrons involved in the bond formation. Okay? That can be sharing or that can be donation, whatever it is. So that's where the number of electrons involved in the bond formation. That's where it is called as valency. What about valence? Valence electrons are nothing but these are the electron present in the outer shell or outermost shell. So this is related to this one. Now this is, you can see, right? Yes. So total number of electrons in the outermost shell. Or valence shell. That's where we have the valence. All of you have understood the difference? So valence electron is total number of electrons present in the outermost shell, and valency means it is the number of electrons involved in the bond formation. When it comes to alkali and alkaline earth metals, that is S block element, so valence electron and valence of the element will be same. No difference. Fine? All of you have understood? Any doubts in this? If you have any doubts, you can ask. Okay? Shall we move to the next one then? Okay? So in that case, next one is, when I am talking about P block element, please remember D and F we are not going to discuss. So we are going to discuss about P block elements. Okay? Because S block and P block, all of them, they are representative elements. S block element and P block element, they are called as representative elements, if you recollect. So D and F we are not going to discuss this year. We are going to discuss that one next year in second period. So that's why group 1, group 2, this statement is applicable. Now when it comes to P block, we have group 13, group 14, group 15, then group 16, group 17, okay, 18, for time being we will not consider because they are inert gas. We will stop at group 17, okay. So if that is the case, what is the valence electron with respect to group 13? It will be 3, it will be 4, it will be 5, it will be 6, it will be 7. So when it comes to group 13 elements, total number of valence electron. So total number of valence electron will be 3. That's how we can easily remember. So that's how we can easily remember when it comes to P block element. If I take group 13 element, so total number of valence electron in group 13 will be 3. Okay, group 13 will be 3. What about group 14? It will be 4. Group 15, 5. Group 16, 6. Group 17, 7. If I include group 18, it will be 8. Except helium. except helium. If I want to include group 18, okay. So for time being, I will include group 18 also. So it will be 8, except inert gas. I will mention here, except helium, except helium. Helium will be having 2, okay. So that's where we have the group 13, 14, 15, 16, 17, 18. So this is where we have the valence electron. ಹಾಗಾದರೆ when it comes to valency or valency, when it comes to valency, okay, now it may vary. Now it may vary in some of the groups. When it comes to group 13, once again it will be 3. When it comes to group 14, it will be 4. But when it comes to 15, when it comes to 15, it will be 3 and 5. It will be 3 and 5. When it comes to 16, it will be 2 and 6. When it comes to 17, it will be 1 and 7. And when it comes to 18, it will be 0 and 8. It will be 0 and 8. All of you can see? Now valence is getting changed. Valence is getting changed. Valence electron, yes, 3, 4, 5, 6, 7, 8. But when it comes to valency, now group 13, 14, they are same. But from group 15 onwards up to 17, group 15, 16, 17, there is a variation. Right? So there is a variation. So therefore, when it comes to these group elements, when it comes to these group elements, valency will be, one is total valence electrons and another one is 8 minus total valence electrons. Okay, so there are two valency will be there. One is total valence electron and another one is 8 minus total valence electron. Okay, so that's why 8 minus 5 is 3. So we have 3 and 5. 8 minus 6 is 2. Therefore we have 2 and 6. 8 minus 7 is 1. So therefore 1 and 7. So therefore valency will be two types. One is total valence electron and another can be 8 minus total valence electrons. Any doubts? Any doubts in this? This is going to help you out in writing the, I can tell, writing the formula of the compounds. It will help you out in writing the formula of the compounds. Okay? So that's where. Shall I remove this? They are all important for your competitive exam point of view. Okay, na? And to write the formula of the given compound, it will help you out. Okay, in that case, we have understood what is the difference between valence electron and valency. Then we have seen how valence electron and valency with related to S block element and P block element. And both are representative elements. Here, we are not going to discuss about transition element. So, inner transition or transition element. We are not going to focus on that. Okay? Fine. So, hagadre the last part of this particular topic, which I can mention, very important because they will ask for 1 mark. They will ask it for 1 mark. That is naming the IUPAC. IUPAC naming of elements. IUPAC naming of elements having atomic number greater than 100. Atomic number greater than 100. So that's where we have the method to name the element. What is IUPAC? International Union for Physical and Analytical Chemistry. Okay, that's where we have the IUPAC naming of elements having atomic number greater than 100. Fine. So, to understand this one, first thing we should know what are the namings, abbreviations which will be given for this particular name. See, for example, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now, according to this naming, 0 it will be considered as nil. 0 will be considered as nil. Okay. And 1 will be considered as un. Then 2 is bi. Then 3 is tri. 4 is quad. And 5 is pent. 6 is hex. And 7 is sept. And 8 is oct. And 9 is n. 9 is n. All of you have understood? So that's where we have 0 as nil, 1 as un, 2 as bi, 3 as tri, 4 as quad, 5 as pent, 6 as hex, 7 as sept, 8 as oct, 9 as n. Okay. So that's where we have some of the abbreviations. That's where we have some of the abbreviations for these numbers. Therefore, for example, I want to name the element with atomic number 101. Okay? Now it's very simple. Every element should be ended up with IUM. Every element should ended up with IUM. That's all. Okay? See, for example, in this case, 1. What is that 1? We have to mention it as un. Okay, we'll make it as capital un. So what is that next? 0. 0 is nil. Then once again 1 is there. So I will write it as onium. Unnilonium. Okay? Unnilonium. That's what we can mention. Name of the element. All of you have understood? Same, if I want to talk about element with 102, then 1 is there, so I will make it as un. Then nil, because 0 is there, nil. Then 2 is there, so I will make it as bium. I will make it as bium. Okay? So that's where we can have the name. If I want to have 103, I can mention it as un, nil, trium. So if I observe here, un stands for 1, nil stands for 0, un stands for 1. At the end, IUN. So un stands for 1, nil stands for 0, bi stands for 2, at the end UM. So un stands for 1, nil stands for 0, tri stands for 3, then UM. So that's where we have to name the molecule or elements, not molecule, elements. Okay? Fine? In that case, in periodic table it is there, Dhanush. If you see 7th period elements, they have used the short form. They have used the 3-letter abbreviation for this. If you see period 7 elements, last few elements, after 100 whichever comes, we can mention like this. Okay? And it is there in periodic table also. Okay? So that's why we have the unnilonium, unnilbium, unniltrium. In that case, can you write name for the element with atomic number 119? With atomic number 119, can you try it out? With atomic number 119. Hmm? Any one of you? Yes, Stefan, you are right. So it will be once again, then enium. Yes, enium. That's where we have the only one capital word. Okay, Bhumika. So that's where 119. Fine. So if I want to go with IUPAC means International Union for Physical and Analytical Chemistry. Okay. So they are there to mention about naming the elements and all to maintain the standard. This one. Okay. It is the international union. Okay. So therefore 119. Yes, real name, that means for some of the elements internationally they will come to agreement and they have given the name of some of the scientists who has contributed. But since there will be some discrepancies, if for example I am an Indian, I want to give the name of 118 element with the person or a scientist of India, but American will not agree for that or Russians will not agree for that. So like that, since there is a disagreement with respect to name of the scientist, so therefore this is an alternative where it will be a common one all over the world. And now among these also some of the element, now IUPAC has given some official name with scientist name only. But you will be asked the question with respect to writing the atomic number. They will give 119, 118 and they will ask you to write the name of the element. IUPAC name of the element. Yes, Rohan, that's what I am telling. For now, some of the element they have agreed. All the world union, they have agreed and they have come to a conclusion for some of the element they have kept some of the scientist name. But still, earlier there was a problem. Okay, so one nation is to give another name, another country is to give another name. So to avoid those confusion, to avoid the confusion and to maintain the uniformity, they have come up with this particular methodology. Okay, fine. Otherwise, yes, what you are telling is absolutely correct. For some of the element, they have given the name of the scientist, and that has been agreed by all over the world. Okay, fine. Any doubts in this? Even in your periodic table, you can see some of the elements. For example, N capital, then nil N, then onium, right? Unu, short form. Unu, we can write. Okay. So here, N, then nil, then by, That will be 3-letter abbreviation. Here, N, then T. Okay. So like that we can have the 3-letter abbreviations also, which is there in your periodic table. For elements they have given these 3-letter abbreviations also. Okay. All of you have understood? So we have to practice with some more numbers. Okay now? So by this we are done with the periodic classification of elements. Class is not over. Don't be happy. Okay na? Class is not over. Still I will take few minutes. Now, any doubts in periodic classification of elements? You have any doubts? Okay. Fine. So in that case, shall we move to the next one? Okay. So next topic is called as chemical bonding. Very important topic. Chemical bonding and molecular structure. Chemical bonding and molecular structure. Very important. Okay, with respect to chemistry. Chemical bonding and molecular structure. Okay, we are done with that one. So names of the elements are given on their properties. Shuchita. Now many elements are not named based on their properties. It's based on their scientist name or laboratory name. Depends. There are different way they have given the names for those elements. Fine. Only few elements will be with their properties. Names have given with respect to their properties. But many elements are given names with respect to the contributor who has discovered or who has contributed towards chemistry. Fine. So that's where we have the periodic classification. Now we are entering into a new topic which is called as chemical bonding and molecular structure. Fine. So what I will do is today we are going to focus on what and all you are going to discuss in this particular topic. Okay. So for example, when it comes to this particular topic, first we are going to discuss about why bonding should be there. Why bondings are existing. Bondings in the sense why elements will be interacts with each other. Why elements has to interact. Okay, so that one will be discussed. Okay, so why an element has to interact. So once the answer is given for this, then how elements are going to interact. Elements are going to interact. So that one we have to give the answer. How elements are going to interact. So first, why? Why a element has to interact with the another element? Why should they interact? Why can't they live alone? If that is the case, I think this world would have been a different case. We would have not been existing only. This whatever sweater I am wearing, that will not be there. Even our body will not be there because all of us are there due to the interaction of elements, due to the compounds. Right? So that's where first point we are going to discuss in this topic is why bondings will be happening. Why an element has to interact. Yes, Rohan, naturally to have the stability, to reach the stability, no doubt. Everything in this world, they are moving towards the stability. Okay? So that's where we have the answer. Anyway, in detail we are going to discuss. Yes, Stephen, in detail we are going to discuss that one. Fine. So next, once we get the answer for that, next, how they are going to interact with each other. Because some element will have some type of interaction, some other element will have some other type of interaction. Yes, all of you are right. We are going to discuss that one. Don't worry. So that's where next one will be how. And then next it will be with respect to how they are arranged. How these elements are arranged. They have interacted, fine. But how they have been arranged. What is the structure? Okay. So that's where next one will be what is the structures of the compound, some of the compound. What is the structure of the compounds? So that's what we are going to discuss at the end. So therefore the name of the topic is chemical bonding and molecular structure. So they are going to discuss about why there is the existence of chemical bond, then how this chemical bond will be formed, then at the end, once we know that yes, they have to interact, and then we know that yes, they are going to interact in these are the ways they are going to interact. Now the next one will be what is the structure then? How these elements are arranged in a compound. That's where molecular structure comes into the picture. All of you have understood? Fine. Any doubts in this? If you have any doubts, you can ask. So that's where we have the chemical bonding and molecular structure. Now when I am talking about chemical bonding and molecular structure, as all of you are writing, why a chemical bond has to be formed? Many of you had written to have the stability, right? Absolutely correct. To have the stability. How they are going to have the stability? By reaching to the octet state. By having the 8 electrons in their outermost shell. Absolutely fine. But that is not universal. That is not universal. We have some of the compound, or we have many of the compounds which will not follow this criteria, but still those molecules are existing. So that's what we are going to discuss in tomorrow's class. Okay, fine. So now, since periodic classification is completely done, you can read the whole topic from textbook and from your check sheet and try to solve some more questions related to that particular topic. Okay, so thank you. Thank you very much. Take care. Don't go outside without your mask, please. Okay, now. So thank you. Thank you. Take care. Yes, yes, yes. Thank you. Yes, bye. Okay.